All right, for the lesson 1 ready, set, go, for the set portion, we have to match some contextual descriptions to a graph. And I'm going to encourage you to read these descriptions a few times because you got to kind of read them and think about them. So in part A, or description A, the amount of money in a savings account where regular deposits and some withdrawals are made. So I know that if I'm adding money, like depositing money, the amount of money is going to increase. If I'm withdrawing, that money is going to decrease. So I'm going to come back to that one. For B, the temperature of the oven on a day that mom bakes several batches of cookies. So I know that for an oven, it's got to like heat up and then if I'm opening the oven to put cookies in or take cookies out, each time I'm opening the oven, I'm going to like lose heat, close the oven, it heats back up. Open the oven again, I lose heat, close the oven, it heats back up. And at the end, once you turn the oven off, well, the temperature goes back down to room temperature. So that one jumped out to me right away as for number 7, if you look at your different graph options, number 7, I think that is going to go with that context in B. So I'm pretty confident. So I'm going to label this, it's the oven temperature that is on our y-axis, and it is time on our x-axis. So over time, after we've heated up the oven, as I open and shut for the different batches of cookies to bake, the oven will get warmer and then it will get cooler. Now, I think we could actually come up with a better graph than that one, but whatever. All right, so we matched B in part C, or context C, the amount of gasoline on hand at the gas station before a tanker truck delivers more. So I know that however much gas is on hand, it's going to keep decreasing until it's fully depleted or until the truck delivers more. So if I look at my functions that are decreasing, I have number 9 and number 11 are the only two that are totally decreasing. And so I might even want to like come back to those, because right away as I think about this, I'm like, all right, would this be sort of like a step function like we see in number 9? Or would this be more continuous like we see in number 11? So out to the side, I'm just going to put C there, and I might need to come back and think about each of these contexts a little more. For option D, watermelons are delivered to a farmer's market every Saturday morning. The number of watermelons available for sale on Thursday. So if watermelons are delivered at Saturday, there would be like a bunch of watermelons. And then as people buy them until Thursday, that number is going to keep decreasing. So I think that is going to go with number 9. I think that this is our watermelon situation, and I think that this is our gasoline situation. And here's why. When you are buying watermelons, here, I'm going to zoom in on this graph. However many melons this is, so our y-axis would be like number of watermelons. When someone buys one or some amount, will jump down, and then who knows, maybe for a long period of time, no one else buys a watermelon, but then another one gets sold, and then another one, and another one. Maybe this jump represented 2 watermelons getting sold. But I do think this data would kind of look like steps, because there might be a stretch like from this time to this time where no melons are sold. Now, if you've ever been at a gas station, this is why I think this one is our gas station one. This would be the amount of gasoline. If you've ever been to a gas station, it's not that there's never a time where no one's filling up with gas, but it seems to happen much more continually. So this would be gasoline in time, whereas this would be, oops, sorry, my OneNote keeps freezing on me. The one above that we just looked at, number 9, would be the number of melons like left at the store or farmer's market. And again, on our x-axis, that would be time. Maybe that's time in days. I'm not sure. All right, going back up to the top. So we have matched B, D, and C. We said we were going to come back to A. All right, in E, the amount of mileage recorded on the odometer of the delivery truck over a time period. And so if I look at the two functions that are left, I have function 10, which is mostly increasing, but it decreases a little. And I have function 8. And the amount of mileage would have to go with function 8 because your mileage recorded on an odometer could stop. Like if you stop driving the truck and leave it in the driveway or leave it at work for like a few days, but that mileage can never go backwards. So the reason that E has to be number 8 is that is the only graph that is strictly increasing. It's always increasing. So this would be mileage on, oops, I misspelled that, mileage on our y-axis. And again, this would be time on the x-axis. And then that leaves A, the money in the savings account, would have to be number 10. So again, like it kind of depends what type of savings account you have. I don't think normally we'd see like little linear steps, but this is the only graph that makes sense. So money in savings account over time, and we said that money's also being withdrawn. So like when the money goes down, that means someone took money out. When it goes back in, that means someone made a deposit, or when it goes back up, I should say. All right, so that is the matching part. And then in question 12, we're given 2 pairs of graphs on 2 different coordinate grids, and we're again asked for a list of similarities and differences. So for number 12, I'm just going to color code these. The line is the one that is in orange, and this is an exponential curve here. So I could say that the one that I highlighted in purple, I don't know how well you could see that, is exponential. Although I know it's maybe not a curve we saw in our last unit. If you're not sure, you could just say that it is a curve. And as for something that these have in common, so like similarities, well, both functions are decreasing. Both functions are continuous. And somewhere in there, it looks like both functions have a point in common. It might be 1,7, but I'm not 100% sure. I think they have the point 1,7 in common. And then for differences, we said one is an exponential curve, the other is linear. Over here, I'd point out that this function is discrete, whereas this function is continuous. I'm going to put a little bar in there, but they both, like they appear to have sort of a constant rate of change. I'm not really sure. The one that's discrete looks a little funny. They're both increasing, so things we could say that they have in common is that they are increasing functions. All right, that's all of the set section.